Hello, everyone. Welcome to Marantis Labs Tech Talks, where we dive into cloud native topics, use cases, tutorials, and many more to educate you all. Uh, I'm Avinash Desireddy, Senior Solutions Architect and Developer Advocate here at Marantis. Joining me today, Eric Gregory, Senior Technical Writer, to talk about introduction to Helm, and he has an awesome demo that has been put together to walk us through how to get started with Helm, when it should be used, etc. Uh, Eric, it was nice to have you here again. Can you please give a quick intro so that everybody knows about you?
Yeah, absolutely. Glad to be back. So, just a little bit of background on me. My name is Eric Gregory. I'm senior technical writer here at Marantis. I wrote the ebook that we published called Learn Containers 5 Minutes at a Time, and I co host Radio Cloud Native with my colleague Nick Chase. My background is as a computer science instructor, and these days I write on Kubernetes, containers, open source, DevOps, and more. All right. So,
Awesome. Thank you, Eric. So just before we jump into the next steps, quick housekeeping items. Please use the Q&A section in the panel, like either on the right or like in the bottom, to post any questions, and we'll get through the questions throughout the session. And following and the session is being recorded, and we'll be sharing the recording as well, and how you will get access to the recording. You'll have the information at the end. With that, Eric, please go ahead.
all right. Thank you so much. So, jumping right in, what is Helm? So Helm often gets called a package manager for Kubernetes. And what that means is it bundles and it templatizes the various YAML manifests for an application, making it easier to install, manage, and publish your apps on Kubernetes. So Helm is maintained outside of the Kubernetes core. And by default, it's used as a command line tool, similar to, but completely separate from kubectl, or however you prefer to say that, kubectl, all the infinite ways. You can also use Helm with a graphical user interface through Lens, and we're going to demonstrate both methods today. So before we do, a little bit of history on Helm. The Helm project began in 2015, emerging from Deis Labs in the early days of Kubernetes and introduced at the very first KubeCon. In its first two versions, Helm had both client-side and server-side components, meaning parts of the tool ran on a Kubernetes cluster. But as of Helm 3, the tool is fundamentally client-side. So the version of Helm that you would be using, this is a client-side tool. And Helm is now an independent graduated project from the Cloud Native Computing Foundation. So there are some terms that some of them are pretty common throughout development, but some have a very particular usage in the world of Helm. So it'll be good to kind of level set and establish these terms up front. The first is a chart. And this is Helm's term for a package of configuration files, mostly YAML, that define Kubernetes resources for an application. The next is a release. So when you install a chart on your cluster, you create a release. That's the specific instance, the particular named instance of the chart specifications on your cluster. So you could have multiple distinct releases installed from the same chart. And then finally, common term, but has a particular meaning here, repository. Charts are stored in repositories, which may be either on the cluster or external to the cluster. In this context, a repository is simply a server where you can download and or publish charts. Okay, so to get started, you don't need to install Helm to follow along with this presentation, but if you'd like to do so, here's how to get started. So one of the easiest ways is just to download Lens. You can do that at k8lens.dev, and Helm is built right into Lens, and we're going to see how that works here in a couple of minutes. So if you have Lens already installed, you could go ahead and bring it up. If you don't, you could go ahead and be downloading it now. It'll be a few minutes before we start really diving into it. The other way to get started is you can download the command line tool. And depending on the system you're using, if you're on Linux, you can use curl to grab an installer script. If you're on Mac, you can use the Homebrew package manager and just run brew install Helm. And if you're on Windows, you can use the Chocolatey package manager and just run choco install Kubernetes Helm. So I'll pause here for just 30 seconds. So if you want to go ahead and do this right now, you can run the commands for your system.
I pasted the links in the chat for anyone to just grab the links and copy paste the commands directly from there.
Awesome. Thanks for tossing those in there. So why use Helm? The simplest answer is that Kubernetes doesn't really include an abstraction for a big picture application, which can be kind of a surprising fact. It's designed in terms of the individual services that work together to comprise a larger application. And then it has abstractions for the components that go into those services as you get more granular, but it doesn't really have a way to conceptualize just an application. And that can be challenging, especially when a lot of configuration goes into a single component of an app. So take a MySQL server, for example. To run this on a Kubernetes cluster, we might need to configure manifests for a deployment, a persistent volume claim, a service, and it could go on past that. Those YAML files start to add up, and important configuration details are now spread out between them. And for a lot of developers, that starts to feel unwieldy. By contrast, here's what it takes to configure a MySQL server using Helm through Lens. So I'm just going to bring up Lens. I've got a Minikube cluster running, and over here in the side panel, I'm under the Apps tab. And so I'm looking at charts. These are charts that are available to me in repositories that I've connected Lens to. So I can just search for MySQL. And I see I've got a couple of different options. I'm going to go with this one from Bitnami. When I click it, I'll get some information on this chart. I can click install. And here I'm going to get some configuration options for the release of MySQL that I'm going to install on the cluster. So we see here I can specify a version. I can choose a namespace if we're working with multiple ones. And I can also specify lots and lots and lots of different values down here. If we come down to the auth section, I can specify a root password for my server. I'm going to go ahead and do that. And then I click install. And simple as that, it's installed on the cluster now. So I can close that and go over here to releases. And that tab is going to show me the actual instances of a chart that I've got on my cluster. So here's my MySQL instance. And we'll look at some of these options a little bit later. But there we are. Easy as that. So the first reason you may wish to use Helm is that it consolidates and streamlines installation, management, and publication at an application level. The second major reason is that it enables you to create and use templated packages. This templating functionality is how we were able to specify configuration details on our MySQL server just a moment ago, like that root password. The chart files were written with parameterized blanks that we could fill in with our own information. So this is a piece of functionality that vanilla Kubernetes doesn't really allow for, but Helm brings templates to bear in order to make its packages more generic and widely usable. We're going to see in a little bit that there is a technology that you can use with Kubernetes that's built into the core that allows you to do templating, but it doesn't have exactly the same use case as Helm. We'll talk more about that in a bit. So we just saw a quick installation of MySQL with Lens. Let's try another installation with the command line interface. So first we'll need to connect Helm to a repository where we can find charts. You saw that I had some available to me in Lens, but I want to add another here using the command line. So we'll use the official repository for the monitoring tool Prometheus. So I'm going to bring up my command line here. Run Helm repo add Prometheus community. And then the address of the repo, which we see is just on GitHub. Okay, Prometheus community has been added to your repositories. And now we're going to run Helm repo update. And that what that's doing is Helm is just looking for any updates from the repositories that I'm connected to. And so it looked through all of them. So you might ask, okay, I had a bunch of repositories there. We just added one. How do I find repositories? One great way is to search for repositories and charts in Artifact Hub. So Artifact Hub is a CNCF sponsored project that serves as kind of a mega repository for Kubernetes artifacts, essentially a repository of repositories, including repos for Helm charts. You can think of it sort of like Docker Hub, but where Docker Hub is dedicated to container images, Artifact Hub lists repositories, including multiple types of Kubernetes artifacts, including container images, core DNS plugins, KubeOrdan policies, and more. And you can see the front page of Artifact Hub there. And we'll actually visit it in a second, but before we do, you can search Artifact Hub through the Helm CLI using the following command: Helm search hub, and then whatever you're looking for. So let's have a look at that. Helm search hub, let's say MySQL again. Okay, we found quite a bit. So it's really designed to be browsed through the web interface. You can browse through the CLI, but this is kind of intended for the web interface. So let's look at the page for the Prometheus chart that we're about to install. Now this is really useful, a lot like Docker Hub, again, in that we have labels for official charts. So the publisher owns the software deployed by this package, and verified publishers. So that can help us to see, okay, is this an official package? Is this one that's going to be supported? Is this one that I can be a little more optimistic, might not have major vulnerabilities or issues in it? Artifact Hub is very useful for that. Okay, so we've added our repo, our Prometheus community repo. Let's install our app. First, we want to understand which configuration values are templated and therefore configurable through Helm. If we have this templating functionality before we install something, we're going to want to know what we can actually configure with the templates. And we can do that with the following command: Helm show values, and then the name of the repo in the chart. So let's bring that up. This is going to give us a fair amount of output. And ultimately, this is the same data that Lens was showing us when we made our configuration of the MySQL server up front. The different configurable values we could scroll through. Now in the CLI, we can't just go straight into it and configure that, but we are being given flags that we can use when we set values with the Helm CLI. All right, so suppose we want to install version 2.34 of Prometheus. We can actually look through the chart versions to see which one uses the application version that we're seeking. And we'll do that with the command helm search repo, and then the repo and chart, and then the versions flag. So let's do that. Okay, we can scroll all the way up here and we can see we have charts other than just baseline Prometheus here on this repo. We've got Prometheus Redis exporter and lots of other things. We can scroll up to just basic Prometheus. And here we see we have two columns. And on the left, we have the chart version. And on the right, we have the app version. So we said we wanted 2.34. The last one running 2.34 was 15.10.3. So we can specify that in our installation. And that's exactly what we're going to do. We'll do that with the command helm install. Now we need to give the name of our release, the name of our instance. So I'm going to call this myprom. And then we need the repo, the chart, and then I'm going to use the version flag, and I'm going to specify chart version 15.10.3. And all right, we're installed. Pretty simple. So just to go over that command again, because this is a pretty fundamental one, and this really gives you kind of the pattern of usage for Helm. We called Helm, we're installing, we're naming our release. So this is now the way we're going to refer to this release and interact with it, upgrade it if we want from now on. We've got the repo and the chart, and then we've got our version flag. So suppose we realized that we actually wanted the most up-to-date version. We thought we wanted that older one, but nah, we want to upgrade. Let's see what that looks like. And we could do that either in Lens or on the command line. Let's do it in Lens. So we go over to Lens. And we see, it takes a second, but then updates. So it now reflects that new release that we have on the system. I'm going to click on it. And here we have information about the release. We can upgrade it with the upgrade button. So this is going to communicate with the repository, bring over some information for us. And all right, I decided I wanted to use a different version. So let's go to the most up-to-date version. And we're simply going to click update. And we have successfully upgraded to that version. But okay, what if we decided, oh, that was a mistake. No, I really did need the older version of the app. We can click on it. And we have rollback functionality. This is very cool. This is going to show us all the different revisions we've made to the release. And we can just bop right back to the first version. Super easy. And we can do all of that on the command line too. We could have run helm upgrade, and notice this is the same usage pattern. We're going to name our release and then the repo and then the chart. So we could upgrade the version that way. We could also roll back on the command line. We could see our revision history the same way we did with the GUI. We could do it on the command line by saying helm history myprom, and then we could roll back by just specifying the revision number. So we could have done the same thing with helm rollback myprom 1. Okay, so we ran through installing and upgrading and rolling back a chart that already exists. And that's one really, really useful function of Helm, but it's not the only one. We can also use Helm for publishing charts. So to publish a chart, you're going to need to have a chart repository available, a place to put your charts. One commonly used one is Chart Museum. That's a widely used open source repository and sub-project of Helm, so also running under the CNCF. And this can run in all kinds of ways on your cluster or externally. You can use a variety of storage solutions, including Amazon S3, Google Cloud Storage, Microsoft Azure Blob Storage, etcd, a local file system, many more options. You can run Chart Museum as a Docker container, which is how I'm doing it. You can install it on your cluster with its own Helm chart. You can also install it on a given machine by grabbing an installation script or using the GoFish package manager for Go. So pretty flexible. I've already got it installed. So now that we have a repository, let's make sure we're building on sturdy foundations when we're putting together our chart. In order to publish a chart, Helm is going to expect us to have 3 key files included. It's going to expect us to have one called chart.yaml, which contains metadata for the chart. It's going to expect us to have one called values.yaml, which is going to set defaults for any parameterized values so that this can just be very quickly and cleanly installed with certain defaults that it'll use that'll probably make sense for the average user. And then it needs to have a templates directory that contains your templatized YAML manifests. So we can generate boilerplate files with the following command: helm create project name. So I've already done that, and I'm going to show you this directory where I've done that. So I created a project called Random Reads, and this is a super simple API that's going to give out reading recommendations, book recommendations. And so if I go into my Random Reads directory, we'll see we've got our chart.yaml, we've got our templates directory, we've got our values.yaml, our key necessary files. I want to show you what these look like in VS Code. So this is not a templatized manifest right here. This is a standard service manifest here. This is what I would use if I was just going to deploy this to my cluster kind of the ordinary way without Helm. So there's a service manifest, and here is the deployment manifest. Now, let's look at what it looks like if we're using a templatized manifest for Helm. Here's a deployment manifest. Note these curly braces giving us values that we can fill in, including some that you can imagine a user might want to specify, right? Like replicas. Now my user will be able to specify how many replicas of this API they want to have running. Here is a templatized version of a service YAML file. Here, the user could specify what port they want to run on. They could specify what type of service type they want to use. Okay, so we're giving them some cool options. And the important thing to take away from this is that these are different types of files, right? While these are YAML, adding these curly braces to templatize certain values makes this a pretty different file. And these, the templatized ones, if we just send that as is without the intervention of Helm to our API server, our Kubernetes API server, it's not going to know what to do. We'll come back to that point. So you need to have Helm to work with these templatized YAML files. Okay, with everything in place, we can use Helm's linter to validate the files. Great functionality here. So I've already put together my files, so I'll just run Helm. I'm clear the screen so we're up at the top, a little more visible. Helm lint random reads. All right, so they'd like me to put an icon in there, but we were linted. We did not fail. We're good to go, and we can package that up with Helm package random reads. Let's do that. Okay, so we successfully packaged our chart and we saved it to random reads version 1.0 TGZ. Okay. Now we can publish the chart to our Chart Museum repository using curl. So this is just going to be an HTTP request. So I'm sending that TGZ file, and I'm sending it to localhost 8080 because that's where Chart Museum is running on my system. And I'm sending it specifically to the API charts destination. And I get saved true. So, okay, this has been saved to Chart Museum. It's available there. Awesome. From here, I can install my chart to the cluster in two ways. I can install it from the Chart Museum repository, but I can also install it from my local directory. If I were going to do it from the local directory, I would simply run helm install, and then I'm going to need to give the release a name. So in this case, I could call it RR. And then I would be specifying that I want Helm to draw from the random reads directory. If I wanted to do it from the local directory, I could. I wouldn't even need to have it zipped up into a package. But I'm not going to do it that way. I'm going to do it from Chart Museum. So first, we're going to need to add the repo to my system, and then we're going to need to install the chart. So the way we'll do that here in a second is we'll run helm repo add Chart Museum, and here I'm just specifying my localhost 8080 address. Then we'll run helm search repo Chart Museum just to see what we see inside the repository. And then we'll run helm install Chart Museum /random reads, and we'll generate a random name for it. All right, let's see what that looks like. All right, so we just added Chart Museum to our repositories. Let's have a look inside, see what we have. And okay, we have stable Chart Museum, and we have Chart Museum /random read. So this is the chart that we uploaded to our actual Chart Museum instance. Okay, so let's install that. Helm install Chart Museum /random reads, and then I want it to generate a random name. All right, we're deployed, and I had it generate a random name. So let's go over to Lens. And I want to see my release on Lens. It'll take just a second. There we are. So, okay, this release is called random reads, and then we have this number here, 16594544287. I can just copy that. And why did I copy that? Well, I would like to see this in action. And Minikube gives us the fun functionality. If you haven't used it before, you can just type in service and then the service name. And it'll give us a tunnel in the browser. And there we go. There's our app. So I have this JSON result, a book recommendation. In this case, the title is The Tale of Genji. The author is Lady Murasaki. Awesome. Everything is working like it should. Okay, so I said before that we, by default, interact with Chart Museum through HTTP requests, and that isn't limited to just adding a chart. We can use this curl command to delete a chart from the repository. So let's go ahead and do that. We'll need to open a new terminal tab, and now it's deleted. All right. that basically does it for the demo. But before we finish, I want to walk through some tips and best practices for using Helm. So first of all, as I alluded to before, once you start writing templatized YAML, you're really committing to Helm because Kubernetes won't understand those files without Helm. Now, sure, you could write some templatized YAML files and some non-templatized YAML files, but that's not really solving the configuration sprawl problem. So you're really going to want to go one route or the other. Your entire team should really be on board with Helm, using it as part of a standardized process if you're using it. Speaking of standardized processes, Helm is a natural fit for a standardized automated continuous deployment process. To the extent that this sounds like your situation, Helm might make sense for you. Third, pretty important point, don't forget about security, especially when it comes to using community charts. Something like Artifact Hub, it's super useful, but just like Docker Hub, it's essentially a public repository, right? So you want to do your research. You want to know that community packages could contain vulnerabilities or suboptimal configurations, and kind of do your due diligence on those. Make sure you know what kinds of tools you're using. And last one, I mentioned earlier that there was another way to templatize deployments on Kubernetes, and this is a way called Kustomize. And very frequently, Helm is framed as in competition with Kustomize. You'll see Reddit threads that are like Helm versus Kustomize. Which do I choose? And it kind of makes sense that it gets framed this way. Kustomize is a templating engine that's built into the Kubernetes core. Unlike Helm, Helm is separate, it's external, but Kustomize is right there in the core. Both provide solutions to some of the same problems, to this issue of YAML configuration sprawl, and both provide some degree of templating functionality. But the templating in Kustomize is more granular, enabling you to create multiple patches for the same configuration files. So you're kind of customizing them for different environments or needs. So you might fill in a value one way for your dev environment, one way for your production environment. That's a common use case. So that's a little bit different than what Helm is doing. Helm is serving as a package manager. Kustomize is serving as a way to manage configuration of the same instance, what would be called a release in Helm, across different environments. So Kustomize is too deep of a topic to explore in depth here, probably deserves its own talk, but from a Helm perspective, the thing to know is that many teams use both tools in a complementary way. So for example, you might use Helm to publish and source packages and Kustomize to help manage configs across environments. And that does us for our talk through Helm. So a little bit of self-promotion here, some further reading. If you're just getting started on your cloud native journey, you can check out my free ebook from Mirantis Press called Learn Containers 5 Minutes at a Time. And very, 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 very soon now, in the next couple of weeks, the next book in the series is going to be coming out. That's Learn Kubernetes 5 Minutes at a Time. So that'll tie in pretty closely to some of the things we've been talking about today. And I'm going to pass over to Avinash now for some of these last slides and for questions.
Awesome. Thanks, Eric. And before going on to these last slides, I wanted to address these questions. So there's one question from Abhijit. The question is how is Helm comparable to Caravels YTT and KApp?
Take a look at the question there. I'm not, do not have any experience using those tools, so I'm afraid I can't say. Do you, Avinash?
No, not really.
Yeah, so we'll be happy to look into that and see if we can provide any information on that in the future. But yeah, I'm not experienced using those.
Okay, thank you. If there are any other questions, feel free to post them in the Q&A section. In the meantime, just wanted to let you know we have 2 more upcoming sessions scheduled for next 2 weeks. So the first one is an insider look into Lens 6 features from Team Lens. So Lens 6 is one of the major releases that happened last week on Thursday, and our engineering team is going to deep dive into the features through an extensive demo, so you can get your hands dirty with all the beautiful features of Lens 6. And the following week on August 23rd, we are going to dive into these container security aspects from one of the senior developer advocate from Sneak. His name is Eric Smalling. He's one of the awesome presenter, and he will be deep diving into the container security aspects.
That sounds awesome.
And I posted the link in the chat where you can find these two events, and please RSVP to these events so you'll get the notifications appropriately, and then join us during these events.
And I see some questions in the chat asking if we'll get the recording and the documents from this presentation afterward. So that will be sent out, right?
Yes, so you will be receiving an email with the link to the recording and then the link to the slides probably on Thursday, and you will have them in email. And all these recordings are available in YouTube. You can also check out the previous Tech Talk recordings in the YouTube playlist under Mirantis channel. Yep. Mirantis is hiring for several roles. If you like to be part of like Team Mirantis, please check out the careers portal and apply from there. And if your profile matches, like, our team will contact you for the next steps. And with that, we can go to the next slide. And thank you everyone for joining us here, and thank you Eric for deep diving into Helm. This was very helpful. There like a lot of new information in terms of like Helm, how to get started with it very easily. Thank you so much.